Good morning. We're going to be talking about angles today and solving for some different angles. Some of this is going to be some vocabulary that we need to get through some basics. So for the first one, we're going to look at consecutive adjacent angles. A lot of times you're just going to see the word adjacent angles. Sometimes you'll see that consecutive in front of it. Simple way to think about it, we're going to say two angles that are next to each other. Now, these angles do need to have a couple of things in common. They need to share a common side and have a common vertex. So, for instance, we have two angles, angle AOC, and I'm going to draw a picture to help illustrate this. So we have angle AOC and angle COB, and they have this common side OC, and you can see that as I've traced over that, we can say that these are adjacent. And we can see that they're adjacent. It says if C belongs to the interior of angle AOB. So angle AOB is this entire angle. Here's try it one more time. Here's angle A to O to B. So I can see it's that whole angle, and I can see C is sitting on the inside of it. Okay, another vocab word we have, the sum of angles on a straight line is a total of 180 degrees. And if I had two angles that did that, we could call them a linear pair. So anytime you see that word linear pair, you want to think straight line totaling 180 degrees. Another thing we need to know is angles at a point. So kind of like this picture below. Angles at a point, if I put them all together, will sum to total 360 degrees. So if we tried this problem below and I want to figure out what is the value of x, or the missing angle, I will label that x. So knowing that they're all sitting at a point, I can add them up and set them equal to 360. So this would allow me to solve for that missing angle. So if we combine all of these constants, I see x plus 220 equals 360. And I want to solve for x. So I'll subtract 220 from each side. And I can show you x is going to be 140 degrees. So knowing that 360 degrees, if I have all of the angles all the way around one point, that's my total that helps me solve for x. Okay, and another definition we have here is vertical angles. So we can say that they're angles formed by two intersecting lines. Now, some important characteristics that come from vertical angles that we need to know. Probably number one is where they're located. They will always be across from each other. And then the other really important thing is that they have equal measures. So if we look at this picture below, I see two line segments, really, two line segments that are intersecting. And it says by definition, if I had vertical angles, well, they should be across from each other. So if I take a look at angle SRU, right, and if I label it, I'll trace it out the way I label it, SRU, that's this angle here. Well, the angle directly across from that, that looks like angle TRV, and that looks like that's the angle that we're trying to solve for here. Angle TRV and angle SRU, well, they're vertical angles. So they're across from each other, so I can tell you, well, they must be equal in measure. It's a total of 52 degrees. So again, I'm looking for those intersecting lines. If I find the lines that I have here, this line or line segment is intersecting with this line or line segment, so I know that those are forming vertical angles. In the same sense, I know that the other two angles on the top and on the bottom across from each other, also vertical angles, also equal in measure. So for this next example, we're going to try and find some values here, some values of x and y, and we're going to show some work to support it. So things to take note of or be aware of. Here I have a straight line. I'm noticing that this angle is marked a right angle, which means that's 90 degrees. And I know angles on a line total 180. So if I look at these two angles right there, I can say, well, 47 plus y plus this 90 degrees should add up and equal 180. Since they're angles, they're all adjacent angles, they're on a line, I know 180 degrees. So if we solved for y, combined the 47 and the 90, subtracted that from 180, we'd be able to find y is 43. Now similarly, we can do that for x. If I notice where x is located, x is over here. And let's take a look at line CD, and I can see how x and this angle of 47 are also next to each other. I also see that they're next to each other on a line. Those two angles are linear pairs, so if I just look at these two, I could call them linear pairs. And from the front, we knew that linear pairs totaled 180. So I could say 47 plus x equals 180. And if we solved for x, I could see that x then is going to equal 133. Okay. Same kind of idea here with this next example. I'm looking, I have one full straight line going all the way across. And if I'm looking at those three angles put together, I can't call them a linear pair because there's three of them. However, they are adjacent angles and they form a straight line, so they're still going to have that property of equaling 180. So if we combine like terms here, get 24 plus 2x equals 180. Subtract over 24, so I have 2x equals 156. And if I divide through by 2, I'm going to find x is equal to 78. Some other type of angles we have are going to be dealing with what's called a transversal. So we're going to draw this picture down here. It says we're going to be given a pair of lines. We're going to call them AB, and maybe CD is over here. It doesn't tell us anything special except for we have two lines, and they're in a plane. It says I have a third line called line EF, and a third line EF is called a transversal if it intersects AB at a single point, maybe I'll call that point E, and it intersects CD at a single point called D. So what we've just drawn here, this line, ED, that's your transversal. Okay, so we want to know, as far as the definition goes for a transversal, it's just a line that intersects two or more lines. And that's what we found with ED. It was intersecting two or more lines. So some pictures that we have that give us some special properties. Now something to keep in mind, these two lines that we're seeing, for instance this one and all of these pictures, they are parallel lines. So they give us some special properties. So whether the lines are parallel or not, the names will still apply. However, knowing that they're parallel will give us the properties at the bottom of the page. So as far as interior angles, I want to look on the inside of my parallel lines, and that would be those four, angles 3, 4, 5, and 6. When I'm looking at exterior angles, I want angles on the outside. So I'm looking at maybe 1 and 2, 7 and 8. I could call those exterior angles. Now if I throw the word alternate in there, so alternate interior means I want one from each side. So I could take a look at angles 3 and 6. Those would be considered alternate interiors. Same thing with angles 4 and 5, alternate interiors. They're opposite sides of that transversal. Now when we get to alternate exteriors, I could take a look at angle 1 and angle 8. I can tell you that those are alternate exteriors. And then I could take a look at angle 2 and angle 7 and same thing. Those are alternate exteriors and they work in pairs. Of Corresponding angles, we get a bunch of these guys. So corresponding angles, I think same side of the transversal, same side of the parallel lines. So for instance, angle 1 and angle 5 would be considered corresponding angles. Angles 3 and angle 7 are corresponding angles. And again, they work in pairs. Angles 2 and angle 6 are corresponding. And angles 4 and angle 8 are corresponding angles. And then lastly, same side interior. Sometimes you hear them called consecutive interior. Just a different name. So consecutive interior or same side interior, think same side of the transversal and both interior angles. So again, they work in pairs. So like for instance, angle 3 and 5. And then I could also look and say angles 4 and 6. So the special properties that we get with these angles, alternate interior angles will always be congruent. And again, properties of parallel lines, that's a big thing here. As long as they're parallel, these properties hold true. Corresponding angles are congruent. Same side interior angles are supplementary, meaning 180 degrees when I add them up. And then alternate exterior angles are congruent. So you notice out of these 4, there's only one that really has a different type of a relationship here, the same side interior angles. So we're going to take a look at this top picture and we're going to see how does this work. And there's many ways that we can get these answers. So for instance, over here I have angle 2. Okay, angle 2, we know, well, we have to find, knowing that angle 1 is 150. So we could say angle 2, well, angle 1 and angle 2 are linear pairs, and I know linear pairs are supplementary, or add up to be 180 degrees. So knowing that, I can say, well, angle 2 has to be 30. Subtract 150 from 180, and I'm going to see 30 degrees. If I look at now angle 3, well, angle 2 and angle 3 are vertical angles, so I know from the front vertical angles are congruent. So I'm just going to make a note over here, vertical angle to 2. Okay, so now angle 4, well, I could do this a couple of ways. I could say it's vertical to 1, meaning it has to be 150. So I'm just going to put over here maybe a couple of options. Vertical to angle 1. Or I could say it's a linear pair with both 3 and 2. So either one, I'll write down 2, knowing again that should be supplementary. Okay, if we move on to angle 5, well, we could look at angle 5 a bunch of different ways. I could say angle 5 and angle 1 are corresponding angles, and we know from the front, corresponding angles are congruent. So I could say it's corresponding, I'm going to abbreviate that, to angle 1. I could also say it's alternate interior to angle 4. So we know alternate interior angles are congruent. So there's a bunch of ways you can see how to get this. Okay, if we look at angle 6, well, angle 6 is going to be, again, if I thought of those properties, alternate interior to angle 3, meaning it has to be equal, and it's going to be equal to angle 3's measure since they're alternate interior. I could also say it's a linear pair with 5. I could say it's the same side interior angles to angle 4. And we said same side interior, well, they had that one property, different property, meaning that they would be supplementary, and I can see they add up to be 180. And if we continue this around, well, I can say angle 7's got to be 30, a couple of ways, vertical to 6. Could also say it's corresponding to angle 3. Okay. And if I take a look at 8, well, angle 8 is going to be 150. Again, we have that vertical angle property. We could also say, if we look back up on top, it's going to be an alternate exterior angle to angle 1. So that's a bunch of different angle properties. If you'd like to try and challenge yourself, try number 5 and we'll check your answers tomorrow in class. It's a good challenge to put all of those properties together and see how well we can do. Okay, hope this helped. Don't forget, like and subscribe.